Hey guys, welcome to lesson 3. Our topic today is use substitution with trigonometric functions. So let's get started with the warm-up. In the warm-up, if you look carefully, as we talked about the tips and guidelines in lesson 2, I said pick your u to be something inside the parentheses, so that would be 5x cubed. And then I also said pick u to be your exponent of e. So let's see, which one do I pick? Sometimes you might try one of them and work with it, and you know what, you might not get the required answer, and that's okay. So you might have to do a second attempt, but let's see and figure out what it would be. So if I picked u to be 5x cubed, so what would my du be? It'll be 15x squared dx, right? So now let's look at what I have and what I want to replace. So if you look here, I have 3x squared, so I'm going to divide by 5, right? I'm going to divide by 5 on both sides, so I have du over 5 equals 3x squared dx. So I'm able to replace this 3x squared dx with du over 5, so I'll have an integral of 1 over 5, and then I have sine of u, and then I'm still left with this. So this really kind of, I would be do cosine of u. That would be cosine of u du. I still have two functions. I'm not really able to get with this, so this would not work. So what do you do in that case? And we're going to try our other tip or guideline that we did is pick u to be the exponent of e. So let's let u equals cosine 5x cubed, right? So now let's take the derivative. So du would be, so when you're doing the derivative of cosine is negative sine, and we don't change the inside, leave it as it is, times the chain rule, the derivative of the inside, which is 15x squared dx. So now again, look at what I have and what do I want to replace with. So I'm going to do it in blue. I have 3x squared, right? 3x squared sine 5x cubed dx. I want to replace, I have sine 5x cubed and x squared. I need 3x squared, whereas I have 15. So I'm going to divide by negative 5. So if I divide by negative 5, I'm left with, it's negative 1 over 5 du equals sine, if I just was to write it as it's given above, 15x, so not 15x squared, it's 3x squared sine 5x cubed dx. Yes, so now all I'm going to do is set up my integral in terms of u. That's what my goal is. So make this integral look something very doable, very easy, right? So I'm going to factor out the negative 1/5, and I'm going to write cosine e to the cosine 5x cubed is u, and that would be du. That's a pretty straightforward integral. The integral of e to the u is just e to the u, so plus rc, and I'm going to replace back my u with whatever I initially let it to be, 5 cosine 5x cubed plus c, and that is my answer. Okay, so again, it's just trying one thing or the other. If sometimes you picked your u to be wrong and it didn't work and you're not able to replace what you have, then you might want to go back and pick a different u. So that's the best way to do it. Look for your tips and guidelines, kind of follow them. Okay, so let's fill out these trig identities. We have done these in the past. You should all know these. You should have them memorized. Sine over cosine is tangent theta. Secant is 1 over cosine theta. Cosine theta of sine theta is cotangent theta. Cosecant theta is 1 over sine theta, right? And then you should know number 4. So number 4 is sine squared theta plus cosine squared theta is 1. 2 and 6 actually come from number 4, which would be 1 plus cotangent square theta is equal to cosecant square theta, and 1 plus tangent square theta is equal to secant square theta, and cotangent theta is 1 over tangent theta. So let's get started with the examples. Our first example is giving us integral of tangent 5x. So here we will have to rewrite it again. Why do we need to rewrite it? Because I do know the derivative of tangent is secant square x, but I don't know what would give me an answer of tangent x. What would be the function? So what do I need to do is I'm going to rewrite it as not cosine, sine over. Can I rewrite it as sine 5x over cosine 5x dx? Going back to your guidelines, right? What do you pick your u to be? Pick something that's in the denominator. So I'm going to say let u equals cosine 5x. So my du would be negative sine 5x in your chain rule times 5 dx, right? Again, look for what you have and what you want to replace. So I'm going to actually start highlighting it. So you have sine 5x, you want to replace this, and dx. So I have sine 5x dx. So I want to get rid of what? Negative 5. So I'm going to divide by negative 5. Divide by negative 5. Divide by negative 5. So I have negative 1/5. Du equals sine 5 sine 5x. Oh, I divided by negative 5. I'm sorry. I don't have this. Yes. Okay. Dx. Right? So now I'm going to replace that back. So this integral would be negative 1/5 will come. I'm going to replace sine 5x dx with this. So, and then cosine is what? Cosine 5x was 1 over u du. So what gives me 1 over u? So the integral of 1 over u is negative 1 over 5 ln of absolute value of u plus c. You're going to replace this back in here. So negative 1/5 ln of cosine 5x plus c. And that is your answer. Okay, don't forget the plus c. Many of you do not write that plus c, so please make sure the constant of integration must be accompanied. Okay, so here evaluate integral cosine cube x dx. So I am going to actually be using one of the known identities here. We know cosine, oops, my pen isn't working. Cosine square x plus sine square x equals 1. So can I rewrite this as cosine square x times cosine x dx, right? Cosine cube can be written as cosine square x times cosine x because I wanted to use this identity. If I was to solve for cosine square x, I will have 1 minus sine square x, right? So I'm going to take this and I'm going to substitute in, and this would be 1 minus sine square x, right, times cosine x dx. So I'm going to distribute the cosine x. I will get cosine x minus cosine x sine square x dx. And why did I distribute it? Because if I have a negative, I can rewrite it as two separate integrals, right? So this would be the derivative of, the integral of cosine x is basically sine x. And how about this part? I'm going to do my u sub here. So I'm going to do this u sub here. So let's say u is, if I was to first, I'm going to rewrite this. Cosine x sine x to the second dx. So now this is something inside the parentheses. So my u is going to be something that's inside the parentheses, which is u is sine x. So du would be what? Cosine x dx. So look at it. This is what I have, cosine x dx, and this is what I'm going to replace with du. So I'm going to just do the second part. So it's negative the integral of cosine x dx would be just du, and sine x would be u square du, right? The integral of u square is u cubed over 3 plus c, and I'm going to bring that sine x down. That's what I brought. Now just need to write in terms of x. I'm going to replace this whole thing back for my u, so it will be sine x minus sine cube x over 3 plus c. Okay, so that is my answer. Okay, I'm going to do 2 more with you guys, and then I feel like you will be able to finish up the remaining lesson. So again, you might end up writing it out. You might have to do more than what is asked, simplify it more than what is given to you. So here, can I not rewrite it as secant square 2x dx, right? So this is what I'm going to write with. So I know the integral of secant square is what? It is tangent, right? Tangent. But I have the 2 inside. We really don't know much about it. So I am going to say let u equals 2x. So du would be what? 2 dx. I just need to replace dx. So dx would be what? 1/2 du. So I'm going to replace that. So my integral will be 1/2 secant square. I'm going to keep it as it is, u du. Secant square u is just tangent u plus c. I'm going to substitute back u with what did I have? 2x plus c. Okay? Now let's try the next one. So here again, I'm going to first rewrite this. I'm going to write it as 7 sine 2x. And then can I rewrite this as cosine 2x to the 2/3 power, right? And this will tell you what you are going to pick your u to be, something that's inside the parentheses. So let u be, I'm going to zoom in here, u be cosine 2x. So du would be what? Negative sine, and this is going to be chain rule, times 2 dx, right? So again, let's check, what do I have? I have sine 2x, I have sine 2x, and dx and dx. So I want to get rid of the negative 2. So I'm going to divide by negative 2. Oops, that's a highlighter. Divide by negative 2 on both sides. So I'm left with negative 1/2 du equals sine 2x dx. So let's substitute that back in. Take a different color. So I'm going to factor out the 7. I'm going to pull out the 7. And this integral times negative 1/2. And I'm left with what? Cosine 2x is just u to the 2/3 power du, right? So now let's take the integral of u to the 2/3. U to the 2/3 is basically just adding 1 to the exponent. So I have negative 7/2, and this would be 2/3 plus 1 is 5/3, u to the 5/3 over 5/3 plus c. So dividing by 5/3 is same thing as multiplying by 3/5. So it would be negative 21 over 10 u to the 5/3 plus c. I'm going to substitute my u back with, what was my u? Oh, cosine 2x. So it's going to be negative 21 over 10 cosine 2x to the 5/3 plus c. So that is my answer. Okay, so I think that would be good. So guys, please finish up the remaining. And if you have any questions, please feel free to reach out. Good luck, guys.